Good afternoon, students, all of you. Last class we studied solubility of solid in liquid. We did solubility of gas in liquid. We did, and we done one numerical on Henry's law. Is it right? One see your notes. Write today's date. Right today we will discuss write today's date. Understood all of you yesterday the concept of solubility of solid in liquid. We did solubility of gas in liquid. That is very important in JEE mains as well as in NEET. They will ask questions from Henry's law. And I told you on the day what I teach, you have to recap at home, at the hostel. And see that any doubt is there in the next session whenever we meet, there we clarify your doubt. Right. Now write heading, write today's date. Today our discussion will be on a vapor prayer. Okay. Today we have to discuss vapor prayer of in our syllabus we have to discuss one vapor prayer of liquid mixed with solid, mixed with solid, liquid with mixed with liquid. Liquid in liquid. See, this is important concept. Vapor prayer of liquid in liquid, and both the liquids are volatile. Very important concept. So in JEE mains they ask questions from mixing, that is vapor prayer of liquid in liquid we have to study, and another concept we have to study in NCERT, vapor prayer of solid in liquid. There are two concepts we have to discuss. One is vapor prayer of liquid in liquid, another is vapor prayer of solid in liquid. That means dissolving solid in liquid. So these two concepts we have to discuss, and here solid is non-volatile. What is this non-volatile? Volatile we will discuss now. This solid is non-volatile. So these two concepts are very important. See what are those two? Vapor prayer of liquid mixed with liquid, and both the liquids are volatile. And here second concept we have to study, vapor prayer of solid. We are dissolving solid in liquid, but the solid is non-volatile. Non-volatile means what? Substance that do not convert it into vapor form. Volatile means what? The substance that converts into vapor form. Liquid to converting into vapor form. Understood, students? So before going to this concept of vapor prayer of liquid in liquid or vapor prayer of solid in liquid, we have to discuss few concepts. Copy this. So these two are very important, students. Before going to these two concepts, we have to discuss few terms we have to know. Clear, students? All of you copied this. Now see, in this we have to discuss before going to these vapor prayer of liquid in liquid or vapor prayer of solid in liquid, I have to discuss first evaporation. So we have to discuss about evaporation. Now see what is evaporation. Simple. See, I am taking a container. This in the container I am taking liquid, so called water I am taking, and here I am placing one Bunsen burner, for heating. What I am doing, I am boiling the liquid by using what? Bunsen burner. This is burner, and inside what I took? Container having liquid. Now what happens, student? As we are giving heat to the liquid, kinetic energy of the liquid molecule increases and they convert into what? Vapor, no? So the liquid is converting into what? Vapor. So what we define for evaporation? Conversion of liquid into vapor form. The liquid is converting into vapor. That process is called evaporation. Understood? Evaporation is nothing but conversion of liquid form into vapor form. So write definition of evaporation. Clear, all of you? So what is evaporation? Conversion of liquid into vapor. That process is called evaporation. And mathematically, chemically, how I am showing H2O in the form of liquid. This is converting into same liquid in what form? Gaseous form. So this is called evaporation. Understood? Simple. No? So write that evaporation is conversion of liquid into vapor form. Understood all of you? Now see, during vaporization, see what happens. The molecules that are present on the surface, see, the molecules that are present on the surface, these will have least intermolecular forces because they are already present in surface, no? So they have more tendency to overcome the attraction and they easily convert it into vapor. As you know, kinetic energy of the molecule inside, they will have different kinetic energies. But average kinetic energy remains same. But the molecules that are present on the surface, as they are on the upper surface, they can easily transform into what? Vapor, compared with what? Liquids that are present in the bulk. Are you getting my point? The molecules inside, they have different kinetic energies. But whose kinetic energy will be least here means the upper molecules will have least kinetic energy, so they can easily transform into gaseous molecule. So during evaporation, what happens? Cooling of gases take place. Why? Because when the molecules are coming out, kinetic energy of the molecule, what is happening? Decreasing. So when kinetic energy is decreasing, system is losing what? Energy. So cooling of gases take place. So here point is what? Make a note during evaporation. So in assertion reasoning conceptual, they ask during evaporation what happens to liquid? Cooling of liquid take place. So that's what you see in summer season. You remember we use what? Mud pot. What? For cooling of water. And you will see on the pot small pores will be, water will be coming in the form of pores. That is due to evaporation. What is happening? Inside the liquid, what is happening? Cooling is taking place. Why? Because when the molecules are coming out, kinetic energy is lost. So cooling of gases takes place. Understood, Amma? So here make a note during evaporation, cooling take place. Cooling take place. What is the reason to take cooling take place? Since kinetic energy of the molecules decreases. So in assertion reasoning, they can ask conceptually during assertion, during evaporation, cooling of liquid take place. Reason, as kinetic energy of the molecule is decreasing during evaporation, the cooling of effect take place. So A is true and R is true, and R is giving explanation to what? A. So here write during evaporation, cooling take place due to decrease in what? Kinetic energy. Decrease in kinetic energy of the molecule. Understood? So this is conceptual. They ask in exam evaporation what it leads. This is what a burner we are using. This is what a vapor. Understood? Clear for all. So during evaporation, as kinetic energy of the molecule decreases, cooling of gases takes place. Cooling of liquid takes place. Right. Now write next factors affecting evaporation. Copied all of it, this one. So next right heading. What factors will influence rate of evaporation? What is meant by rate? The how much amount of vapors are coming out in unit interval of time is called rate of evaporation. No? So write factors affecting rate of evaporation. Right heading factors affecting. Are you following, students? What factors will influence in exam conceptual? They ask the rate of evaporation. What is meant by rate? Rate means how fast vapors are coming out, rate of evaporation. So there are three factors which influence rate of evaporation. See, what are those three factors? One is, it depends on nature of liquid. Nature of water? Liquid. So what type of liquid we are taking? It depends. Based on what? Rate of evaporation. We will discuss what is those nature of liquid. The second category is surface area. Surface area. So more, if the surface area is more, what happens? The relative tendency to convert into vapor will be more. So second factor depends on what? Surface area. And the third factor, it depends on temperature. As you know, in states of matter first year, with increase in temperature, kinetic energy of the molecule increases. So what happens? More water molecule can transform into vapor. So there are three factors which influence rate of evaporation. So what are those? Copy this: nature of liquid, surface area, and temperature. These three factors will influence rate of evaporation. Now let us discuss one by one. Now see how this nature of liquid will favor rate of evaporation. There are, see, between the liquid there will be intermolecular forces. Between the liquid molecules, intermolecular forces will be there. So if the intermolecular forces are strong between the two liquids, tell me, will be the rate of evaporation will be more or less? If the interactions are more, means they cannot transform into vapor, no? So molecules that are having lesser intermolecular forces, they will have more rate of evaporation. Do you agree? And the molecules that are having more intermolecular force of attraction, since the molecules are attracted more, their tendency to convert into vapor will be less. Correct? So here, make a note, it depends on intermolecular forces. It depends on IMF. I abbreviate with IMF. What is IMF, student? Intermolecular forces. Right, full form you write, you people write, IMF means intermolecular forces. Tell me, rate of evaporation, how it is related with intermolecular forces? Rate of evaporation is inversely or directly. More is the intermolecular forces, lesser is the rate of evaporation. Do you agree? So it is inversely proportional to intermolecular forces. If the intermolecular forces between the liquid is more, so what happens? Tendency to convert into vapor will be less. Following, students. For example, see, I am taking a diethyl ether. What is the formula of diethyl ether? C2H5O C2H5. Later we study organic chemistry. In 11th class you may studied this diethyl ether. And I am taking alcohol, ethyl alcohol. And I am taking water. Now see, when you compare these three intermolecular forces, diethyl ether will have least intermolecular forces because there is no existence of H bonding. You know what is H bonding? In 11th class you studied chemical bonding. So intermolecular forces for this diethyl ether will be less. Next, when you compare alcohol and water, water will have more intermolecular forces than compared with alcohol. So this is the order of intermolecular forces I wrote. So this is what order of IMF. Now, if the order is this one, so what will be the rate of evaporation, students? So conceptual they ask now, if diethyl ether is having lesser intermolecular forces, can I say its rate of evaporation will be more or not? So hence when I take order of rate of evaporation, tell me, this is intermolecular forces I wrote. So what will be rate of evaporation? Will it be inversely or related? Inversely or not? So order of rate of evaporation will be diethyl ether comes what, students? This will have more rate of evaporation, no? Transforming of liquid into vapor will be more because intermolecular forces are less. Then comes whom? Ethyl alcohol, and least tendency to convert into vapor will be for whom? Water. So is it depending on intermolecular forces or not, students? That's what we took here. It depends on the nature of liquid. Are you following? So if intermolecular forces would have been asked, diethyl ether will be less. But rate of evaporation would have been asked, diethyl ether will have more. That means how is the rate of evaporation related with intermolecular forces? Inversely related. Clear, understood, simple. So more the intermolecular forces, lesser is the rate of evaporation, right? So now coming to surface area. So as surface area increases, what happens to rate of evaporation? Increases. More is the surface area. That's what whenever we want to cool the hot tea we want to drink immediately. What we do, we take saucer, no? So in the saucer, when we take hot tea, what happens? Surface area will be more. What happens? More evaporation take place, and the tea gets cooled immediately. So hence, what we say, rate of evaporation, how it is related with surface area? Rate of evaporation is inversely proportional or directly proportional to surface area. So more is the surface area, more is the rate of evaporation. Understood, students? Surface area is more, rate of evaporation will be more. Now see, let us see what will be the influence of temperature. As you know, when temperature increases, what happens to kinetic energy of the molecule? Kinetic energy increases, no? So molecules will more transform into what phase? Gaseous phase. So here what we say, rate of evaporation is directly proportional to temperature. So there you write, with increase in temperature, kinetic energy of the molecule, what happens? Increases. So rate of evaporation, what happens? Increases. Hence we say temperature is directly proportional to rate of evaporation. So this is what how factors will influence the rate of evaporation. Conceptual they ask in exam. So conceptually also you have to be strong in a statement form or in assertion reasoning they can ask in exam. Clear? It doesn't mean that numerical only we have to be strong. Conceptual, every concept from NCERT line to line we have to study. So understood, these are the three factors which influence the rate of evaporation. This will be the order of rate of evaporation. Clear, understood. Now we go for next concept, condensation. Now, till now we studied evaporation. Next we have to study condensation. What is meant by condensation? It is just the opposite to evaporation. No. So evaporation means what we learned, conversion of liquid into vapor. Condensation means what? Opposite. Return back of gaseous molecules into liquid state is called condensation. Right, next heading, condensation. Right, condensation. So what is condensation? Conversion of gaseous molecules into liquid state. Right, conversion of gaseous molecule or vapor phase into liquid phase. No? It is just opposite to evaporation. Now see here, when do we get condensation? Previously we took the vessel, no, having what, water, and we boiled it by using what, Bunsen burner. So what happened, this now I am placing lid over it. Previously it was in open vessel. Now what I am doing, I am placing a lid over it. I covered with lid. Now what happens, see, these molecules which have been evaporated on the surface, here the gaseous molecules form, no. So these gaseous molecules, now there is no chance to go outside, correct, because we covered with water lid. So what they do now, they return back to what form, ground, into liquid state. So the conversion of gaseous molecule further into liquid state is called condensation. So that how you write H2O of liquid transforming into sorry, this is H2O of gaseous form get transformed into what state? Liquid form. That is called condensation. And you heard about equilibrium in first year. Do you remember in 11th class we studied equilibrium chapter? At the stage of equilibrium means what happens whenever equilibrium is established, how much amount of liquid has been converted into vapor, the same amount of vapor what it does condense. So you remember at the stage of equilibrium what happens, rate of evaporation will be equal to rate of condensation. At what stage both will keep on continue? At equilibrium stage, no? So a stage will come at that stage. What is that stage we learnt in 11th class? Equilibrium. So here you write at the stage of equilibrium, when the equilibrium will be established. When will be equilibrium established? Till you cover with lid. If you don't cover with lid, what happens? There will be no existence of equilibrium. You remember generally reversible reaction carried in closed vessel. So at the stage of equilibrium, what happens is the rate of evaporation will be equal to rate of condensation. Here what we can conclude, rate of evaporation will be in equilibrium with rate of water condensation. This is at the stage of where, students? At the stage of equilibrium. So how much amount of liquid gets transformed into vapor form? The same amount of water what it does, it will condense. That is at the stage of where? Equilibrium stage. Following, students. So till now what we learned, what is evaporation we learned, what factors will influence evaporation. Next we discuss the condensation. Clear up to here everyone? Simple. Now next we have to discuss a new term, important term, vapor pressure. See, now we are getting a new term, vapor pressure, very important. Now what is vapor pressure? See, so the pressure exerted by vapor. See, this is the vapor, no? This is the gaseous molecules which have been transformed from liquid. They are exerting pressure on where? Surface of the liquid. The pressure exerted by the water, the gaseous molecule, the pressure exerted by whom? Gaseous molecule on the surface of liquid at a given temperature, keeping temperature constant, and that pressure we are calling what? Vapor pressure. Are you getting my point? So vapor pressure will arise only in where? Closed vessel, because there is no chance of gaseous molecule to escape in outside, no? So write definition of vapor pressure. Is it clear all of you? So what is vapor pressure? I repeat, the pressure exerted by the gaseous molecule on the surface of a liquid at a given temperature is called vapor pressure, and now onwards we abbreviate with VP. What is VP? Vapor pressure. So write next heading, vapor pressure. Now onwards, vapor pressure we represent with the symbol VP. Now what is VP? Write definition of vapor pressure. The pressure exerted by vapor on the surface of liquid at a given temperature is known as what? Vapor pressure. Understood? Simple. So vapor pressure is nothing but the pressure exerted when the liquid is converting into vapor. Since the vapors have no chance to go outside, they are exerting pressure on the surface of liquid at a given temperature. That pressure we are calling it as vapor pressure. Clear, student? This is important. That's what we have to study: vapor pressure of liquid in liquid and vapor pressure of solid in liquid. So before to that, you have to know what is meant by vapor pressure. Now, right, next, factors affecting vapor pressure. What factors will influence vapor pressure? So conceptual they ask in exam, right? Factors affecting vapor pressure. Now see students, in these factors affecting vapor pressure, there are two factors which influence vapor pressure. One, it depends on nature of liquid, same as what we taken in evaporation. So one, it depends on what? Nature of liquid. Nature. It depends what type of liquid it is. Second factor, it depends on temperature. So what is the second factor? Temperature. So these two factors will influence vapor pressure, but keep it in mind, vapor pressure is independent on surface area. So vapor pressure is an intensive property. You know what is intensive in thermodynamics? First year you people learned property of a system that depends independent on amount. So here very important, keep it in mind, vapor pressure of a liquid is independent on surface area. I abbreviate with VP. VP means vapor pressure of a liquid is independent. It doesn't depend on what, student? Surface area. Whereas rate of evaporation depends on surface area, but vapor pressure, as it is intensive property, it is independent on surface area. This is important. So conceptually you have to know important points. In exam they give in the form of statements. So vapor pressure of a liquid is independent on surface area. What the reason? Since it is intensive property. What is intensive in thermodynamics? First year you people studied property of a system which doesn't depend on amount. So once in exam they asked, I have taken 5 liter water in a vessel, and in another vessel I have taken 10 liter water in another vessel. So what will be the vapor pressure in 5 liter and 10 liter vessel? If I ask you the vapor pressure in whether I take in 5 liter or in 10 liter, it doesn't depend on amount. Both the case my water will have same vapor pressure. That means it is what property? Intensive property. And even if I take 5 liter vessel in cylindrical vessel or rectangular vessel, it doesn't depend. It doesn't depend on the size, shape of the container, and such property what we call intensive. So in exam they ask conceptual, when a liquid is taken in cylindrical vessel and rectangular vessel of same liquid 5 liter, whose vapor pressure will be more, would have been asked what you go by. Both the case vapor pressure comes same. Why? Because it is what property? Intensive property. So here make a note, it is independent on amount of liquid, how much amount you are taking, as well as what? Shape of container, size or shape. Understood, students? So vapor pressure is intensive property. So it doesn't depend how much amount you are taking, or how much or what the size or shape of container we are conducting the experiment. Now let us discuss in this nature of liquid. First we have to discuss, see what factors we wrote now. One, it depends on nature of liquid. In this nature of liquid we come across two types of liquid. One is volatile liquid. One is what? Volatile. Volatile means what? The liquid that have more tendency to convert it into vapor. So generally which will be volatile means organic liquids are volatile. Like what? Benzene, carbon tetrachloride, diethyl ether. So if volatility is more, can I say vapor prayer will be more or not, student? More is the volatile. What is meant by volatile? Conversion of liquid into vapor. And the one that is non-volatile. What is meant by non-volatile? The one that is having more intermolecular forces, they can't convert easily into vapor. So is it depending on the nature of liquid or not? And who will be taken as non-volatile? The one that is having more intermolecular forces. Like what? Water. H bonding will be there. And hydrofluoric acid. In 11th class you studied chemical bonding. Hydrogen bonding arises. Ammonia. These are all what? Non-volatile. Why? Because they are having less tendency. They can convert, but condense to convert into liquid will be more. But volatile liquid, whom you take generally organic liquids. What are the organic liquids? Benzene. Benzene in 11th class you studied carbon tetrachloride, carbon disulfide, toluene. These are all what? Volatile liquids. Organic liquids are generally taken as volatile. So if it is volatile liquid, do we get more vapor prayer or not? Do you agree? If volatile liquid is there means what? Vapor prayer will be more, and non-volatile will mean vapor prayer will be less. Do you agree? So is it depending on nature of liquid or not? Copy this. So these are all having H bonding, means intermolecular forces are strong. The one that is having more intermolecular forces will have less tendency to have vapor prayer. Are you following, students? So this is what nature of liquid. Now we go for effect of temperature. Right, next heading, copy this first. Then we go for how temperature will have influence on vapor prayer. This is important. Put star mark for effect of temperature. Copied. Right, next slide. Effect of temperature on vapor prayer. Now observe here all of you, very important. This is effect of temperature on vapor prayer. Now see how temperature will have influence on vapor prayer. As we learned just now, with increase in temperature, kinetic energy of the molecule increases. Correct. So more molecules can transform into vapor. So hence what we say, the rate of evaporation increases exponentially with increase in temperature. That means as temperature increases, vapor prayer of the liquid increases exponentially. Right, that as temperature increases, rate of vapor, the rate of evaporation or vapor prayer of a liquid, you write. Vapor prayer of a liquid of a liquid increases in what way, student? Vapor pressure of a liquid increases exponentially. In how it will increase? Exponentially it will increase. So this is important. See, a scientist called in the name Clausius Clapeyron. What is the name of the scientist? There is one scientist in the name of Clausius. Spelling I write here, Classius. Clausius Clapeyron is one of the scientists. He has given one relation, just like in first year also you studied equilibrium constant. You remember Kp. So what is that relation? See, here I am writing that relation, log P2 by P1. That is, what is P1 and P2? Partial pressure. That is vapor pressure. That is equal to delta H. You remember in thermodynamics, enthalpy of vaporization by 2.303 R. R is universal constant into 1 by T1 minus 1 by T2. This is the relation given by Clausius Clapeyron. That means, see, if T2 is high, T2 is more compared with what? T1. What happens to enthalpy of vaporization? This magnitude is increasing, means enthalpy of vaporization is increasing, no? When enthalpy of evaporation numerator is more, means how is P2 compared with P1? P2 is more than vapor pressure is increasing or not? Hence, what he said, when you plot a graph between what versus what? Vapor pressure versus temperature. Vapor pressure we abbreviate with Vp. So, when we plot a graph between vapor pressure versus temperature, see the graph how it will be, it increasing like this exponentially. So this graph, this vapor pressure is increasing exponentially. So what happens to vapor pressure of liquid? Right, that with increase in temperature, vapor pressure of a liquid increases exponentially, and that relation was given by the scientist. What is the name of the scientist? Clausius Clapeyron. And this is the relation log P2 by P1, where P2 is what? Vapor pressure of liquid 2, vapor pressure of liquid 1. What is delta H? Enthalpy of vaporization. In first year thermodynamics you people learned. Conversion of liquid into vapor. And this is 2.303 R. R is universal gas constant. T1 is the temperature. T2 is the temperature. This relation is important. Keep this relation in the box. So from this we can conclude that rate of evaporation is increasing exponentially. And show this graph. Here I am following our reference. Right. Now write next heading BP. What is BP? Boiling point. Put star mark. See, till now we discussed what is vaporization, what is evaporation, what is condensation, what factors will influence rate of evaporation, what factors will influence vapor pressure, and how temperature will have influence on the vapor pressure. Now next we have to discuss boiling point. Right heading BP. Right, BP. Now what is BP, students? Boiling point. Right, boiling point. Put star mark. Boiling point. You know, no, students, what is the boiling point of water? Water boils at where? What temperature? 100 degrees Celsius, no? So at what we define for boiling point, the temperature at which the vapor pressure of a liquid is equal to 1 atmospheric pressure. So getting my point, suppose see we plotted a graph no just now between what versus what we plotted, vapor pressure versus temperature we plotted no. So we got exponentially like this no, and imagine this is atmospheric pressure. See, this is 1 atmospheric pressure. At 1 atmospheric pressure, this point corresponds to what, students? This point corresponds to boiling point. So what we define for boiling point, the temperature at which a liquid will boil. At what pressure? 1 atmospheric pressure. That point we are calling as boiling point. So write definition of boiling point. So what is the definition of boiling point? Write definition. The temperature at which the vapor pressure of a liquid is equal to how much, student? Is equal to 1 atmospheric pressure no. And that point what we are calling BP. See, this is the point where my liquid will boil because its pressure is coming to how much? 1 atmosphere. And this is important. It's star mark for boiling point. In exam conceptual they ask you graphical approach. Following all of you. Now see, I am taking liquid A. This is liquid A. I show you with another curve. This is liquid B. This is with liquid C. This is with another liquid D. Now call this ABCD liquid. And this is liquid A, liquid B, liquid C, liquid D. Now tell me the boiling point of B coincides with this, no? Boiling point of this C coincides with this temperature. Boiling point of this D coincides with this. Understood? Now tell me among AB, arrange in increasing order of boiling point for A, B, C, D. Lowest boiling point to highest boiling point. Now in this A, B, C, D, tell me which is having the least boiling point, means can I say A comes lowest boiling point? Correct, do you agree? So A comes lowest, next to A comes who? This is A boiling point, next is this is B boiling point, this is C boiling point, this is D boiling point. Understood, Amma? So A less than, B less than, C less than D. This is what increasing order of boiling point. Clear all of you? But if I ask you vapor pressure, students, if I ask you increasing order of vapor pressure, so keep it in mind, vapor pressure is inversely proportional to boiling point. Very important. So more is the vapor pressure of a liquid. If the liquid is having more tendency to convert into vapor, that is what exerting more vapor pressure means, its boiling point will be more is the vapor pressure, lesser is the boiling point. Are you catching my point what I am saying? If the vapor pressure of the liquid is more, means its boiling point will be how, student? Less or not? So if I ask you vapor pressure of these four liquids, how will be the order? Inverse, no? The one that is having less boiling point will have more vapor pressure. Do you agree? Understood all of you? So the one that is having less boiling point will have more vapor pressure. Then comes B, then comes C, then comes D. So in exam conceptual questions they can ask you in the graphical approach. This point is important. So keep it in mind, vapor pressure is inversely proportional to boiling point. So more is the vapor pressure of a liquid, lesser will be the boiling point. Do you agree? If the vapor pressure is low, boiling point comes to be more. That means more heat is to be required now to convert it into vapor. If vapor pressure is less, means Understood, students? This is the order of boiling point. When vapor prayer, if they ask a converse, that means in inverse of this we get vapor prayer. Clear? Alright, next heading. Classification of substances, last 2 minutes. Right, classification of substances based on vapor prayer. Up to this clear all of you, right? Alright, last 2 minutes. Right, classification of substances. Classification of substances based on vapor prayer. Based on what? Vapor prayer. On the vapor prayer, we are dividing the substances into two categories. What are those? Just now we don't know. Volatile and non-volatile. So one is what? Volatile. And another one is what? Non-volatile. So that's what in the heading, in the introduction I wrote. Liquid mixed with liquid, both are volatile. Now getting idea all of you, we are dividing the substances into two categories. One of volatile, another is non-volatile. Then what is meant by volatile? Substances whose P naught, what is P naught? Vapor prayer of the pure solvent is not equal to 0. That means they have tendency to convert it into vapor. Substances that can convert it into vapor. That means P naught is not equal to 0. Whereas non-volatile means what? Substances which cannot convert into vapor. That means whose P naught value will be equal to what, student? 0. Then what are volatile liquids means? You can take all organic liquids like water, you can take either, either is ROR and alcohol. So these are all what? Volatile. Whereas non-volatile means whom you take sucrose. Sucrose is a biomolecule, carbohydrate we study, and fructose, urea. These are all what, students? Solids, no? Do solids will have tendency to convert it into vapor? No, no. So for those substances we are calling as what? Non-volatile. What are those? Sucrose, fructose, urea. Such solids are called non-volatile. Whereas the liquids that are converting into vapor are called what? Volatile. Got idea all of you? What is this ROR, student? In organic chemistry you people study either. What is ROH? Alcohol. And tomorrow we continue with vapor prayer of liquid in liquid and vapor prayer of solid in liquid. The two concepts are important. There we study Raoult's law. Up to this clear? No? So tomorrow while coming, read and come. I am ending the session. Bye all of you. Wish you all the best. So I am closing this. Copy this till this.